Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at using the derivative formulas that we've learned already in combination with each other. So we've learned 7 rules for differentiation. We know how to find the derivative of a constant, of a power of x, of a constant times a function, a sum or difference of functions, a product of functions, a quotient of functions, and then a function raised to a power. What we're going to take a look at is using a lot of these rules together, particularly the product, quotient, and power rule. From my many years teaching calculus, I found that students would be able to do the calculus part of the question, but had a lot of difficulty in simplifying their answer. So I really want to focus on that in this video. So let's take a look at some examples. So in my first example, we have a product of 2 powers, x squared minus 3 to the 4th power times 2x cubed plus 1 to the power of 2. So this is my u, this is my v. So I've outlined my product rule, and you can do these things at the side just to keep you on track, but we've got our product rule. We know how to differentiate a product. We identify u as our first factor, and we then differentiate it using our power rule. So n times this to the n minus 1 times the derivative of what's inside, which would be 2x, and then I just combined 4 times 2x to get 8x. V, I do the same thing. I differentiate it with the power rule. So it will be n times this function to the n minus 1. 2 minus 1 is 1. And then I look inside and I multiply by the derivative of this, which is 6x squared. And then I just multiply 2 times 6x squared to get 12x squared times this. Now I plug into my rule. So my derivative will be equal to u, which is x squared minus 3 to the power of 4, times v prime, which is 12x squared, times 2x cubed plus 1, plus v, which is 2x cubed plus 1 to the power of 2, times u prime, which will be 8x, times x squared minus 3 cubed. So I just plugged into that rule, u v prime plus v u prime. The calculus part is done, but this is where students struggle. They're not sure how to simplify this, and I've seen students try to expand this. They multiply everything out. That's not the way you're going to simplify. What we're going to do is we're going to factor. So we look for the largest factor that can come out of this term and this term. So if I have something, a factor to the power of 4 in this term, and that same factor to a power of 3, I can factor out that to the power of 3. I can only go with the smallest exponent, but that goes into both terms. Then I have a 12x squared here, I have an 8x. Well, I can factor out, the largest thing I can factor out is a 4x. 4x divides into 12x squared, it also divides into 8x. Then I look at this factor, 2x cubed plus 1. It's in this term as well as this term. It's to the power of 2 here, but it's only to the power of 1 there, so I can only factor it out to the power of 1. So I'm taking each of these factors out of this term and this term. So in other words, I'm dividing this by this, and what will I be left with? When I divide this to the power of 4 divided by it to the power of 3, I'm left with x squared minus 3 to the power of 1. When I divide 12x squared by 4x, I'll end up with 3x. And when I divide 2x cubed plus 1 divided by 2x cubed plus 1, it will cancel. I do the same thing with my next term. I factor this out of this term, which means I divide this into this. So when I divide this by this, I'm going to be left with 2x cubed plus 1 to the power of 1. When I factor or divide 8x by 4x, I'm left with a factor of 2. And when I divide x squared minus 3 cubed by x squared minus 3 cubed, it cancels. I'm going to leave all of this factored. I don't want to multiply any of that out. However, what I can do, because this expression is partially factored, I don't like that, I can get rid of my grouping symbols and add like terms. I'm going to move the 4x out front, and so I'll be left with 4x times x squared minus 3 cubed times 2x cubed plus 1. And then inside here, I'm going to get 3x cubed minus 9x plus 4x cubed plus 2. Last step, combine like terms. So I have 3x cubed plus 4x cubed would be 7x cubed minus 9x plus 2. So once you've completed the calculus part, you still have quite a bit of work left in order to simplify this. Let's take a look at an example with a quotient, and we'll use these same functions for u and v since we've already differentiated those. In our second example, we have the same functions for u and v as we did in the previous example, but now we have a quotient. So we need to know our quotient rule, which is I've stated at the side here. So again, we plug these things into this formula. So my derivative will be equal to v, which is the denominator, so 2x cubed plus 1 squared, times u prime, which is 8x, times x squared minus 3 cubed, minus u, which is x squared minus 3 to the 4th power, times v prime, which is 12x squared, times 2x cubed plus 1, all over v squared. So I'll just write it like squared like that, and then I will simplify. Again, in order to simplify the numerator, I need to factor out whatever I can out of both terms, whatever's common to both terms. So let's start with, we've got 8x here and 12x squared here. So let's factor out a 4x out of both. Then I have a 2x cubed plus 1 to the power of 2 here and to the power of 1 there. So I can factor it out to the power of 1. I have an x squared minus 3 to the power of 3 here and to the power of 4 there. So I can factor out x squared minus 3 to the power of 3. When I factor these factors out of here, in other words, I divide that by this, 8x divided by 4x leaves me with 2. 2x cubed plus 1 divides into that, leaves me with 2x cubed plus 1. This divides into that and will cancel. Then I'll have minus 4x goes into 12x squared 3x times. 2x cubed plus 1 cancels with 2x cubed plus 1. And then this goes into this, x squared minus 3 to the power of 1. My denominator will look like 2x cubed plus 1 squared and squared again. My rules of exponents say that will be to the power of 4. What I want to do now is get rid of those grouping symbols and combine like terms. So I'm going to have 4x cubed plus 2 minus 3x cubed minus minus gives me plus 9x. Because I don't have room, I'm just going to take 4x cubed minus 3x cubed and get 1x cubed there. I'm just going to change the order here. I'll have 9x, and then I had a 2. So hopefully I didn't lose anybody on that. I just took these, expanded, and combined like terms. Now what I'm going to do is, because it's totally factored now, I have a factor of 2x cubed plus 1 in the numerator. I also have 2x cubed plus 1 to the 4th power in the denominator. So if I cancel out one of those, I'll end up with that. So I can express this as 4x times x squared minus 3 cubed times x cubed plus 9x plus 2 all over 2x cubed plus 1 to the power of 3. That would be the simplified answer. That's what you're going to be expected to do. You're not done when you plug into your derivative formula. There's still lots of algebra that needs to be completed to get your answer in simplified form. I'd like to do more of these combinations of rules, and I would like to do with fractional exponents because that gets even a little trickier. So practice as many of these as you can, and then when you're ready to face fractional exponents, move on to the next video. Okay, take care and we'll see you then.